Hello, and welcome to TrainSignal. I'm Don Jones, and this is the Different Types of Databases lesson in the Database Administration Fundamentals course. In this lesson, we'll be covering some of the fundamental concepts about databases, including defining what a database actually is. We'll look at three different types of databases that you may work with: flat file databases, hierarchical databases, and relational databases. So what is a database? Well, simply put, it's a collection of data that's stored in an electronic format. Generally, the format of that data is designed to make reading and updating the data quick and easy. Kind of like a phone book, only a lot faster to query because you don't have to flip through pages, and much easier to correct, add to, and update over time. In this lesson, I'll be starting to introduce you to some key pieces of terminology, and I'll try to call that to your attention so that you know these are things you need to remember. The first is the term query. Those are the instructions given by you or an application to the database computer to tell it to retrieve specified data from the database. For example, in this case, the query is asking for customer ID number 34, and so that information, the query results, are retrieved from the database and either given to the user or, more commonly, given to the application that the user is using. Another key term is index. This is a special secondary data structure that helps speed up selected queries. It's kind of like an index in a book. For example, the query now is, "I'd like the customer named Adams." Well, if the data isn't stored in alphabetical order, and on the right side of the screen you can see that it's not, the data is actually stored in numeric order by the customer's ID numbers 1, 2, 3, 4, 5, 6, and 7, the index can sit in the middle of that lookup process. The index can be listed alphabetically if that's how we want it, and so it's easy for the database to quickly go straight to the customer named Adams and then use that as a cross-reference to look up the actual customer record by its ID number. Two more key terms for you. A database server is a special kind of server that stores a database and responds to queries by client applications or users. Microsoft SQL Server is one kind of database server. Typically, Microsoft SQL Server, or just about any other database server really, runs on a server operating system. So it's kind of important not to confuse those. In fact, the term server really comes into play about 3 different times. You've got the server, and that's the actual hardware box that all the software runs on. The server operating system, which in our case will probably be Windows Server. And then the database server, which is software that runs on the operating system, and in our case, that'll be Microsoft SQL Server. There are many other types. There's Oracle, MySQL, many others. The next term is RDBMS, or Relational Database Management System, and that's the type of database server that SQL Server actually is. That's the type of database server that most high-end commercial or professional database servers are. And it's just a collection of software that arbitrates or controls or mediates access to a database. The idea with an RDBMS is, well, really 2 different things. The first is that you've got multiple users or client applications all trying to work with the data at the same time. Let's say it's a sales entry application for a large organization. You're very likely going to have several different salespeople and monitoring people and shipping people all trying to access that data at the same time. And so that's what the RDBMS software does. It mediates that access so that all the different users can have the appropriate access they need. The RDBMS, the relational portion, is something that we'll talk a little bit more about in this lesson, and it tells you the type of database system that this is. Now, speaking just of Microsoft SQL Server, we need to think about how it physically stores all of that data on disk. SQL Server does use standard disk-based storage to keep its data, and it can do that in up to 3 different types of files. you'll always have a file with an MDF file name extension, and that's the primary data file. That's the file where the majority, or at least a portion, if not all, of your data actually lives. You will also normally have an LDF file, which is the log file. And we'll talk more in this and future lessons about what that log file is for, but briefly, it's designed to keep track of all the different changes that are made to the database. That way, if there's a problem with the database, the log can be used to help reconstruct those changes and put the database back to rights. Sometimes a SQL Server database will include one or more NDF file, or secondary data files. These are often used when you have a very large database and you want to spread it across several different disk or storage volumes. By putting some of the data into an MDF and other data into one or more NDFs, those physical files can be put wherever you like. That's one way to give SQL Server a little bit more power to scale, in other words, to deal with larger amounts of workload. You see, disks are, well, they're fairly slow physical devices, at least as relative to the rest of what a computer can do. So the disks often wind up being your performance bottleneck. One way to mitigate that bottleneck is to have more disks involved in the database. And the way to get more disks involved is to spread your data across many different disks. And that's what the MDF and NDF file allow you to do. The first type of database out there is called a flat file database, and you may have worked with these already. If you've ever put data into an Excel spreadsheet, for example, you've created what is essentially a flat file database. These are very simplistic in design. Other formats can include something like a comma-separated values, or CSV file, a tab-delimited file, or TDF, and so forth. For example, this image from Windows Notepad shows a very simplistic flat file database. This database has got 5 different data items in it, widgets 1 through 5, and each of those data items has 3 different pieces of information about it. The name or ID, widget 1, the color, blue, red, green, and so forth, and then a price. The next type of database is a hierarchical database. This is a database that's similar to a tree structure, with parent items, each of which can contain one or more child items, which can contain more child items, and so forth. This is very much like the file system of a computer. In fact, this image from Windows Explorer shows that tree view. Over on the sort of left-hand side of that image, you'll see how there are drives and folders, which have subfolders and files, and those subfolders have more subfolders and files, and so forth. So this creates a sort of a tree. The different pieces of data don't necessarily relate to one another, and some purists would argue that the file system isn't really a proper database at all, but it is. It stores data. It stores it in a way that makes that data easy and quick to change and update. It's just designed to organize that data in a specific way for a specific set of uses, mainly our use as a human being, trying to organize things into folders, because that's how we're used to organizing things in an office environment, for example. A relational database is the third type of database, and it's the type that we'll be spending the most time on in this course. This is the real databases, like SQL Server, MySQL, Oracle, and so forth. Essentially, a relational database consists of multiple flat file tables. So really, that flat file, that CSV file that we looked at a moment ago, is the foundation for a relational database. If you could think of a bunch of those different Windows Notepad images, each one storing a different type of data. Maybe one is customers, another is items that we sell, and another one is orders, where customers have ordered items from us. Those are all essentially flat file tables, and that's what they're called in a relational database. They're all connected to each other, or related in some fashion, which is why this is called a relational database. And in this image, you can see what's called an Entity Relationship Diagram, or ERD, that shows the different flat file tables, those are the big square boxes, and then the lines between them indicate how they relate to one another. Here's a larger version of that image so that we can talk about what it's showing us. Let's start over on the left-hand side where you'll see a box for students. So this is a flat file table, and it lists various pieces of information about these students: their first name, last name, their address, the city that they live in, and so on. This is related to a number of different other flat file tables. If we follow the lines, for example, down toward the bottom of the image, there's a grades table. And one of the things in the grades table is the student ID that a particular grade goes with, as well as the course ID that the grade goes with. You'll notice that the grades table also connects to the courses table. So a grade is given to a student for a particular course. That's an English description of the relationship between these pieces of data. So is a spreadsheet, such as a file that you might work on in Microsoft Excel, a database? Well, sort of it is. It's definitely a flat file type of database. A real database is able to store massive amounts of data, hundreds, millions, possibly even billions of different rows, to use a spreadsheet term. A spreadsheet, on the other hand, is generally not able to store massive amounts of data. Excel, for example, tops out after a few thousand rows. A real database is used to access data very, very quickly, whereas a spreadsheet is not. If you needed to find a particular piece of information in a spreadsheet, you'd find yourself scrolling up and down quite a bit, which is certainly not very quick. A real database is organized into tables, which consist of rows and columns. So a single row in a table might represent a student, and the columns would contain information for that student's first name, last name, address, and so forth. A spreadsheet is laid out in almost exactly the same way. Excel calls it a sheet instead of a table, but it is still organized into rows and columns. A real database is able to utilize all of a server's hardware resources to service thousands of different users at once. A spreadsheet, on the other hand, is only able to utilize a little bit of a computer's capability and is typically designed to be accessed by a single user at a time. A real database has columns that can contain formulas, and those can calculate the contents of that column based on the contents of other columns. For example, a student might have a grade point average or GPA column that's calculated by reading the individual grades that have been assigned to that student. A spreadsheet can do much the same thing. So while there are similarities between a spreadsheet and a real database can do much more. It's designed to quickly access massive amounts of data on behalf of many different users at the same time. Now for some more key terms that you should remember. The schema is the design of the database, and that describes the type of data that can be stored. When we looked at that entity relationship diagram, that's one way of visually seeing the schema or design of the database. The schema doesn't tell us what data is in the database, but it does tell us what that data looks like. The schema usually uses terms like entity to represent a single element or a row from a table. A student, for example, is an entity. A course is an entity. And even a grade that's been assigned to a student for a particular course is an entity. A domain is a type of information, or more commonly considered, a column from a table. So within the type of entity for a student, we would have domains like the first name, the last name, the city, the mailing address, the state, and so forth. And again, that ERD, or entity relationship diagram, is a drawing or diagram of the database schema, showing us all of the entities, usually as boxes, and within each entity, showing individual rows or lines to show us the domains of data that we're tracking for that particular entity. In this lesson, we covered some of the fundamental terms that you'll need to know as you begin working with Microsoft SQL Server. We talked about what a database is, and we looked at an example of a flat file database, which, although it's simplistic, does form the basis for everything that SQL Server does. We also looked at hierarchical databases, using Windows Explorer as an example, and started to talk about relational databases, including the key part about them, the relationships between the different tables or entities in the database.